All right, so last section we talked about exponential functions. This section we were talking about logarithmic functions. And so the relationship between these two is that they are inverses of each other. So the inverse of an exponential function is called the logarithm function. With base a, it's denoted by log base a. So you can see kind of the relationship here, and we'll talk about how we can convert from one to the other, because it is an important thing that you will need to know, how to convert from a log equation to an exponential equation and vice versa. So for now, let's look at this one, log base 5. And before we do this, I guess we could mention the rules for a. So these are the same a's. So that the base a here, and this is also called the base in the exponential. If you remember from last time, a is greater than 0, a is not equal to 1. And that same rules apply for this a, because they are the same a. You can convert from one to the other. In this case, B and C are the same, would be the same numbers as well. But just like A has to be positive, not equal to 1, here, same thing, A is positive and not equal to 1 here. So let's look at this. And the way to kind of do these, and you can do these without a calculator. You can do some of them without a calculator. And this is one that you can do without a calculator. So the way to do this is we want to convert this to, so you think of this kind of like, you could say this equals y, I guess. And so let's convert this to an exponential equation, and we might be able to figure out what y is. So the way to ask this question is, what exponent do you need to raise 5 to that would make it be 125? And the answer is 3. So 5 cubed is 125. And that's the way to do it. So if you're asked to find a logarithm, what number do you need to raise it? What exponent do you need to raise the base to in order to get that number? So if it's log base 2 of 4, the answer would be 2, because 2 squared is 4. So that kind of thing. Next one, write the logarithmic expression log base 4 of w equals r in exponential form. And so kind of the way I think of these, the base is 4, so the base is going to be 4 in the exponential. And then these two are going to switch sides. So w is on the same side as 4, and this one is going to be on the opposite side in this one. And that's just kind of an easy way to remember. The base is the base. The base of the log is the base of the exponent. And then the other two numbers or variables will switch sides from the 4. All right, so we can talk about, and I did not put this on here, but log base 10 of x or whatever is called the common logarithm. And common because it comes up a lot. And we usually just write this as log of x. So if the base is 10, you don't really need to write the base. It's kind of like this is 1w, you don't need to write the 1. Same thing here. This is base 10, but you don't need to write the 10. The other one that comes up a lot is the natural logarithm function. So this is with base e, and we have not talked about e, I don't think, but e is an irrational number, kind of like pi, and it's approximately equal to 271828, but it goes on forever, and we'll be using that quite a bit in this class. So the logarithm with base e is called the natural logarithm, and we use ln of x for this. So whenever you see ln of x, that means it's log base e. If you ever just see log x, that's log base 10. The natural logarithm function is the inverse of the natural exponential function, e to the x. So this is just the same kind of conversion. This is log base e of b equals c. We can convert that to an exponential function where e is the base. All right, so we have some properties that we can talk about. And the first property is just basically the cancellation. So the fact that these are inverses of each other, we can use that. So if we have log base a of a to the x, the a's and the log cancel out, and we just have x. And then likewise, and this works with any of them, but we'll use e. So if we have e to the ln of x, the e and the ln are inverses, and they cancel each other out, and we just have x. So you use that a lot when we're solving equations. That's usually what that's used for. Now, the next ones can also help us solve equations. This first one, or I guess number 2, log of x plus y is, or I'm sorry, I wrote that wrong. Log of x times y. Log of x times y. We can split that up and say that's log of x plus log of y. If we look at log of x divided by y, we could write that as log of x minus log of y. And then the last one, if we have an exponent, so let's say log of x to the n, we can bring the n down as a coefficient. So n times log of x. So depending on the complexity of the equation, you may or may not need some of these. But they're definitely useful in many of the problems. So let's look at evaluate ln of e to the 4th and ln of 25. So ln of e to the 4th, ln and e just cancel out, and that's just going to be equal to 4. Of course, you can put this in the calculator, but it's kind of a good skill to have to not need to do that. If you can do it without the calculator, that's probably a better way to go. Then we have ln of 25. Now this one, you can't put this in the calculator. So essentially what you're looking for here is this log base e. So e to the what, or 2.71828 and on to what exponent would equal 25. Well, that's not going to work. So we can't really do that one. So let's put in ln 25 in the calculator, and we get an irrational number. And typically these are going to be rounded off at 4 digits. So we'll put 2189 for that. So this one, both of these you can put in the calculator, but this one you have to put in the calculator. All right, solve ln of x equals 5. Now there are 2 ways to do this. You can convert this to an exponential equation. So we'll write both of these out. You only have to do one of these. I think this way is kind of a simpler way, but it doesn't really translate to more complex equations. But what you can do, because this is log base e of x to equals 5. So if we convert that to an exponential equation, that is what it is. And that's all you have to do. And that's the answer. X is e to the 5th. And if you fill that in, ln e to the 5th, that does equal 5. So we know that. I mean, that's basically this, but with a 5 instead of a 4. The other method, and this method would translate to more difficult equations, more complicated equations. And that is, we can use the property, the opposite property of this. So it would say e to the ln of x, that would just equal x. But we're going to raise both sides of this equation. We're going to put e as the base. So if ln of x equals 5, then e to the ln of x has to equal e to the 5th. So that's all we're doing. So now that e and the ln cancel out, we just have x, and that equals e to the 5th. And you can put that in the calculator if necessary, but that's the exact solution. So this method 2 here, that's the way that probably should be comfortable working with these, because we'll see some in a minute where it's just easier to do it that way. All right. Next, write these as a single logarithm. So we're going to use those properties, mainly 2, 3, and 4. So the first thing you want to do is kind of get rid of the coefficients. So the coefficient can come up to, or go back as an exponent. So ln of a plus ln of b to the 1/2. Now, so we'll just say that's property 4. And now we're going to use property 2, and we're going to find these ab to the 1/2. And that is it. All right. Next one, 3 ln of u minus 2 ln of 5, same process. We're going to bring the coefficients up as exponents. So ln of u to the third. And you could do, you can leave the minus, or you can make this a -2 and bring up the negative. Either way, it doesn't really matter. But we'll just make it ln of 5 squared, which of course is ln of 25. And then now we have subtraction. So this will be worked out as division. So, or combined, I should say. And so we have u to the third, and then we'll just make that 25. 5 squared is 25. All right, and then the last one, same thing, put the coefficients up as exponents, and then combine. Now this one we have 3 terms. So the way you work with 3 terms, just kind of do them, combine all the pluses together. If you have multiple minuses, combine those. But the general thing to remember is that anything that is positive, so these two are positive, these are going to go in the numerator of the final answer. So x times y to the a, and then this one has a minus, so it's going to go in the bottom. And there you go. Yeah, so make sure you're comfortable with those properties. The easier you can work with those, again, solving the equations will be pretty simple. So we'll look at solving some equations in the next video.